Welcome back to True Heroes, and in today's video, we're diving into the life of a true hero in the realm of science, a man who defied the odds and transformed our understanding of the universe, Stephen William Hawking. January 1942, March 14, 2018, was an English theoretical physicist, cosmologist, and author who was director of research at the Center for Theoretical Cosmology at the University of Cambridge. Stephen Hawking's scientific contributions are nothing short of revolutionary. His research focused on the fundamental aspects of the universe, including the nature of black holes, the origin of the cosmos, and the interplay between quantum mechanics and gravity. His groundbreaking work on black hole radiation, now known as Hawking radiation, challenged existing paradigms and continues to influence theoretical physics profoundly. Born on January 8, 1942, in Oxford, England, Stephen Hawking was an English theoretical physicist, cosmologist, and author. He was the director of research at the Center for Theoretical Cosmology at the University of Cambridge and held the prestigious position of Lucasian Professor of Mathematics at Cambridge from 1979 to 2009. Hawking was born into a family of physicians. Despite their family's financial constraints, both his parents attended the University of Oxford. His mother, Isabel Eileen Hawking, was born into a family of doctors in Glasgow, Scotland. His father, Frank, was a medical researcher. Education. At the age of 17, Hawking began his university education at University College, Oxford, where he received a first-class BA degree in physics. He then began his graduate work at Trinity Hall, Cambridge, where he obtained his PhD degree in applied mathematics and theoretical physics, specializing in general relativity and cosmology. In 1963, at age 21, Hawking was diagnosed with an early-onset slow-progressing form of motor neuron disease that gradually paralyzed him over decades. But this didn't stop him. After the loss of his speech, he communicated through a speech-generating device, initially through the use of a handheld switch, and eventually by using a single cheek muscle. Hawking's scientific works included a collaboration with Roger Penrose on gravitational singularity theorems in the framework of general relativity, and the theoretical prediction that black holes emit radiation, often called Hawking radiation. He was the first to set out a theory of cosmology explained by a union of the general theory of relativity and quantum mechanics. Hawking achieved commercial success with several works of popular science. His book A Brief History of Time appeared on the Sunday Times bestseller list for a record-breaking 237 weeks. He was a Fellow of the Royal Society, a lifetime member of the Pontifical Academy of Sciences, and a recipient of the Presidential Medal of Freedom, the highest civilian award in the United States.
Can you hear me? According to the Bashango people of Central Africa, in the beginning there was only darkness, water, and the great god Bamba. One day Bamba, in pain from a stomach ache, vomited up the sun. The sun dried up some of the water, leaving land. Still in pain, Bamba vomited up the moon, the stars, and then some animals. The leopard, the crocodile, the turtle, and, finally man. This creation myth, like many others, tries to answer the questions we all ask. Why are we here? Where did we come from? The answer generally given was that humans were of comparatively recent origin, because it must have been obvious, even at early times, that the human race was improving in knowledge and technology. So it can't have been around that long, or it would have progressed even more. For example, according to Bishop Ussher, the book of Genesis placed the creation of the world at 9 in the morning, on October the 27th, 4004 BC. On the other hand, the physical surroundings, like mountains and rivers, changed very little in a human lifetime. They were therefore thought to be a constant background, and either to have existed forever as an empty landscape, or to have been created at the same time as the humans. Not everyone, however, was happy with the idea that the universe had a beginning. For example, Aristotle, the most famous of the Greek philosophers, believed the universe had existed forever. Something eternal is more perfect than something created. He suggested the reason we see progress was that floods, or other natural disasters, had repeatedly set civilization back to the beginning. The motivation for believing in an eternal universe was the desire to avoid invoking divine intervention to create the universe and set it going. Conversely, those who believed the universe had a beginning used it as an argument for the existence of God as the first cause, or prime mover of the universe. If one believed that the universe had a beginning, the obvious question was, what happened before the beginning? What was God doing before he made the world? Was he preparing hell for people who asked such questions? The problem of whether or not the universe had a beginning was a great concern to the German philosopher Immanuel Kant. He felt there were logical contradictions, or antinomies. Either way, if the universe had a beginning, why did it wait an infinite time before it began? He called that the thesis. On the other hand, if the universe had existed forever, why did it take an infinite time to reach the present stage? He called that the antithesis. Both the thesis and the antithesis depended on Kant's assumption, along with almost everyone else, that time was absolute. That is to say, it went from the infinite past to the infinite future, independently of any universe that might or might not exist in this background. This is still the picture in the mind of many scientists today. However, in 1915, Einstein introduced his revolutionary general theory of relativity. In this, space and time were no longer absolute, no longer a fixed background to events. Instead, they were dynamical quantities that were shaped by the matter and energy in the universe. They were defined only within the universe, so it made no sense to talk of a time before the universe began. It would be like asking for a point south of the South Pole. It is not defined. If the universe was essentially unchanging in time, as was generally assumed before the 1920s, there would be no reason that time should not be defined arbitrarily far back. Any so-called beginning of the universe would be artificial in the sense that one could extend the history back to earlier times. Thus it might be that the universe was created last year, but with all the memories and physical evidence to look like it was much older. This raises deep philosophical questions about the meaning of existence. I shall deal with these by adopting what is called the positivist approach. In this, the idea is that we interpret the input from our senses in terms of the model we make of the world. One cannot ask whether the model represents reality, only whether it works. Model is a good model if first it interprets a wide range of observations in terms of a simple and elegant model, and second, if the model makes definite predictions that can be tested and possibly falsified by observation. In terms of the positivist approach, one can compare two models of the universe. One in which the universe was created last year, and one in which the universe existed much longer. The model in which the universe existed for longer than a year can explain things like identical twins that have a common cause more than a year ago. On the other hand, the model in which the universe was created last year cannot explain such events. So the first model is better. One cannot ask whether the universe really existed before a year ago or it just appeared to. In the positivist approach, they are the same. In an unchanging universe, there would be no natural starting point. The situation changed radically, however, when Edwin Hubble began to make observations with the 100-inch telescope on Mount Wilson in the 1920s. Hubble found that stars are not uniformly distributed throughout space but are gathered together in vast collections called galaxies. By measuring the light from galaxies, Hubble could determine their velocities. He was expecting that as many galaxies would be moving towards us as we're moving away. This is what one would have in a universe that was unchanging with time. But to his surprise, Hubble found that nearly all the galaxies were moving away from us. Moreover, the further galaxies were from us, the faster they were moving away. defrosting the pizza, let alone cooking it. You can actually observe these microwaves yourself. Set your television to an empty channel. A few percent of the snow you see on the screen will be caused by this background of microwaves. The only reasonable interpretation of the background is that it is radiation left over from an early very hot and dense state. As the universe expanded, the radiation would have cooled until it is just the faint remnant we observe today. Although the singularity theorems of Penrose and myself predicted that the universe had a beginning, they didn't say how it had begun. The equations of general relativity would break down at the singularity. Thus Einstein's theory cannot predict how the universe will begin, but only how it will evolve once it has begun. There are two attitudes one can take to the results of Penrose and myself. One is that God chose how the universe began, for reasons we could not understand. This was the view of Pope John Paul. At a conference on cosmology in the Vatican, the Pope told the delegates that it was okay to study the universe after it began, but they should not inquire into the beginning itself, because that was the moment of creation, and the work of God. I was glad he didn't realize I had presented a paper at the conference, suggesting how the universe began. I didn't fancy the thought of being handed over to the Inquisition, like Galileo. The other interpretation of our results, which is favored by most scientists, is that it indicates that the general theory of relativity breaks down in the very strong gravitational fields in the early universe. It has to be replaced by a more complete theory. One would expect this anyway, because general relativity does not take account of the small-scale structure of matter, which is governed by quantum theory. This does not matter normally, because the scale of the universe is enormous compared to the microscopic scales of quantum theory. But when the universe is a Planck size, a billion trillion trillionth of a centimeter, the two scales are the same, and quantum theory has to be taken into account. In order to understand the origin of the universe, we need to combine the general theory of relativity with quantum theory. The best way of doing so seems to be to use Feynman's idea of a sum over histories. Richard Feynman was a colorful character who played the bongo drums in a strip joint in Pasadena and was a brilliant physicist at the California Institute of Technology. He proposed that a system got from a state A to a state B by every possible path or history. Each path or history has a certain amplitude or intensity, and the probability of the system going from A to B is given by adding up the amplitudes for each path. There will be a history in which the moon is made of blue cheese, but the amplitude is low, which is bad news for mice. The probability for a state of the universe at the present time is given by adding up the amplitudes for all the histories that end with that state. But how did the histories start? This is the origin question in another guise. Does it require a creator to decree how the universe began? Or is the initial state of the universe determined by a law of science? In fact, this question would arise even if the histories of the universe went back to the infinite past. But it is more immediate if the universe began only 15 billion years ago. The problem of what happens at the beginning of time is a bit like the question of what happened at the edge of the world, when people thought the world was flat. Is the world a flat plate, with the sea pouring over the edge? I have tested this experimentally. I have been round the world, and I have not fallen off. As we all know, the problem of what happens at the edge of the world was solved when people realized that the world was not a flat plate, but a curved surface. Time, however, seemed to be different. It appeared to be separate from space, and to be like a model railway track. If it had a beginning, there would have to be someone to set the trains going. Einstein's general theory of relativity unified time and space as spacetime, but time was still different from space.
Professor Hawking has agreed to answer